Welcome to Introduction to GitOps. In this lecture, we are going to learn the following topics together. What is GitOps? What problem is GitOps trying to solve? How or why was the term GitOps invented? And how does GitOps work? Let's get started. What is GitOps? GitOps is a set of best practices that treats Git as a single source of truth for infrastructure-related changes. This means no more command line triggered changes to infrastructure from a decentralized system. GitOps learned from the principles established by DevOps of doing software deployment from a codebase in a version control system like Git. In DevOps, we perform code reviews before merging a change in the codebase. After changes have been made, a CI/CD tool will pick the changes from Git and then build and deploy those changes, right? These practices have helped companies reduce incidents when doing software changes. Strangely enough, that's not usually how infrastructure changes are made in most teams, and this is a problem that GitOps is trying to solve. We want to apply those same principles for software development and redirect them to infrastructure-related changes as well. So up until this point, we've defined that GitOps help engineers find a way to pave the road for infrastructure changes to be automatically deployed, taking the best practices from DevOps, but from an infrastructure perspective instead of a software perspective. Adopting GitOps principles require developers to streamline a process that automatically deploys changes made to our infrastructure as soon as a change is made to the Git repository. In GitOps, we treat Git as a single source of truth. Now, I've seen confusion around this. Is an infrastructure automation taken care of by the infrastructure as code practice already? To answer those questions, let's take a step back. Forgetting about GitOps for a moment, infrastructure as code in itself is the practice of having our infrastructure written in files. Infrastructure means servers, network configurations, load balancers, and other infrastructure-related services. Everything needs to be written in a readable format by humans, but also in a domain-specific language to interface with machines. If we go back in a time machine, in the past, you had to have a group of field engineers go into a physical site to mount the servers and have the system and network configurations applied to them. Skipping forward to the virtualization era, where a sysadmin would create a cluster of servers through VMware by repeatedly clicking on a UI to create servers. Now, in traditional infrastructure as code, you have a DevOps engineer writing and applying the changes made in infrastructure as code files to automate infrastructure changes, which avoids the slow, repetitive, error-prone clicking that happened in the virtualization era, which is good all in itself, is it? So let's explore why infrastructure as code in itself has some room for improvements. Let's assume a scenario where a DevOps engineer wants to make changes to an infrastructure. A clone of the Kubernetes deploy files version in Git will be made to the system. Changes to the file related to the infrastructure will be made. Now, we have files with a desired state of the infrastructure locally. Changes will be applied through the command line to reconcile the desired state in our local to the actual state of the infrastructure. If there are any issues while applying the changes, let's say we get a syntax error in the YAML deploy files, then we will go through a correct repeat process until everything looks fine. And then lastly, at the very end, we push our changes to Git. And this is exactly how GitOps is fundamentally different. By adopting GitOps, you will no longer make changes to the scripts locally. We don't want local changes to modify the cloud infrastructure before they have been merged to our Git branch. You will instead make changes to Git first. Have a process that more closely resembles the traditional CI/CD for software deployment. This is to take advantage of having a branching strategy in place, have pull merge request processes through code reviews, CI/CD pipelines with integrated tests, etc. And also, by having a single source of truth, now there's a history traceable for every change being made to the infrastructure. So if there's an issue, we can trace who made the change and everything. So now that we've seen the differences between traditional infrastructure as code and GitOps, we could say that, in a way,
GitOps is a form of infrastructure as code enhanced. Okay, so moving on. Why GitOps? Before you get confused with the terminology, remember that we, as humans, like to name things. GitOps is just a name that was coined for an operational framework that outlines a series of best practices to follow. Naming things in the software industry is very common, and the goal is to encapsulate a series of concepts and practices to follow. As it happened with DevOps, if a term becomes popular, it starts to get adopted by more companies, and in consequence, we become aware of it. All right, so moving on to the last section. Let's see, how does GitOps work? We just learned that instead of having someone make changes to the infrastructure from his command line, on GitOps, we push the changes to Git, make them go through code review, pull merge request, and then what? As an example, let's assume we have a YAML file with infrastructure definitions for a Kubernetes cluster. Now, we make a change to the number of replicas on our Kubernetes cluster by following GitOps patterns. So we will push our changes to Git instead of using kubectl apply. And this is basically where GitOps-based tools like Flux or Argo CD will come into play. Continuing with this example, a tool like Argo CD will fetch the Git repository, and once it notices a new commit has been made, it will build the new infrastructure based on the Git repository changes. Argo CD uses a pull model for doing continuous deployment. On the contrary, a tool like Jenkins uses a push model. In push model for CI/CD, you have a tool do the build and deploy for the artifacts to the cluster. In pull model, you keep the CI portion the same, but instead of pushing the changes with the new container version to the cluster, now you have a tool that is constantly syncing your Git repository changes. If there is a drift between the desired state and the actual state, Argo will deploy the latest changes. So, summarizing all we've learned, GitOps and DevOps complete each other. Git is the single source of truth. There are GitOps based tools for continuous delivery like Flux or Argo. GitOps is good software delivery practices used for infrastructure deployments. And that is it. Thank you very much for attending this lecture. Goodbye.